Hello there, and welcome to Ocean Files on YouTube. Modern technology enables even massive vessels to stay stable in severe weather conditions. Interestingly, some of the ships engineered today can even self-right themselves when flipped by waves. Here's a look at the technology that renders ships unsinkable. We frequently see large vessels such as cargo ships that weigh hundreds of thousands of tons, retaining stability even when battered by large waves. When a ship navigates the ocean, it endures various forces and pressures from the waves and wind. To ensure survival, every ship constructed possesses a ship stability system, essentially the ship's balance while afloat. Thus, when the vessel is rocked by waves or wind, the ship can right itself. Multiple devices help maintain ship stability, including bilge keels. Bilge keels bear a wing or fin-like shape, are stationary, and attached to the ship's hull sides. The bilge keels span about 2/3 of the ship's length, and their stability effect escalates as the ship gains speed. Another stability device type is the anti-rolling tank, a tank designed to stabilize the ship's position when the ship leans left or right. It spans the ship's width. When the ship leans to either side, water within the tank flows, substantially diminishing the ship's rolling motion. The anti-rolling tank comes in two forms, active and passive. In an active rolling tank, the water flow mechanism within both tanks is more complex, utilizing a pump. The next stability device type is the active fin stabilizer, resembling a fin and used to lessen the ship's rolling or tilting motion. The fin stabilizer is affixed to both hull sides of the ship and can move in multiple directions, controlled by the ship's sensitive gyro system. When the ship rolls or tilts, the sensitive gyro system dispatches a signal to the activating system in the form of electro-hydraulics. However, active fins aren't very effective when the ship cruises at speeds below 10 knots or approximately 18 kilometers per hour. Container ships have an anti-heeling system, a servo control system engineered to keep the ship level during loading and unloading at ports. Anti-heeling cannot function as a stabilization system in open seas and is only operable when the ship loads or unloads containers at a port. The anti-heeling system is employed to detect the ship's inclination angle and to automatically balance the ship by transferring water into the ballast tank from right to left, or vice versa. The anti-heeling system comprises a main control panel, pump start panel, and anti-heeling pump. The anti-heeling system's performance can function automatically and manually. Furthermore, a ship's stability system is affected by its balance points, which dictate the ship's stability magnitude. Consequently, the ship's balance points must consistently be monitored by the crew. This is vital, as one of the leading accident causes is overlooking the ship's stability calculations, whether the ship is at sea or in the harbor. Following this, rescue ships are deployed for search and rescue operations to assist victims of marine accidents at sea. However, during these rescue missions, severe weather conditions and towering sea waves can obstruct SAR operations. Moreover, they can potentially cause the ship to overturn. To combat this challenge, global engineers have conceived rescue ships with the notion of self-righting boats, which can revert to their initial position even when tipped 180 degrees. Beyond their self-righting ability, these boats can attain high acceleration and endure various harsh sea conditions. Several corporations produce these self-righting boats, including the Royal National Lifeboat Institution, or RNLI, situated in the UK. A few critical components are integral in crafting self-righting boats that empower them to flip back independently. The first element is the initial design of the ship, where all weighty equipment and objects need to be placed as low as feasible within the ship. The second element is the crew's operation and control area, which must be light, robust, and filled with air. Moreover, the crew's access door must be watertight to prevent water infiltration when the ship is capsized. On self-righting boats, a pendulum system is also installed, designed to block water from penetrating the ship's interior. During operation, when the self-righting boat capsizes, the weights in the pendulum system hang vertically, leading all open sections to close automatically, thereby barring water from entering the ship. These self-righting boats also incorporate an onboard system that detects if the boat has capsized. This system safeguards the boat by shutting down the radar and engines before righting the boat back to its initial position. Once the boat reverts to its normal position, the radar and engines reboot. Furthermore, crew members within the boat need to be seated and secured with safety belts to guarantee their safety during a capsizing incident. That concludes this video. I trust you found it enjoyable. Do subscribe to this channel to ensure you don't miss out on any of our new content. See you next time. The modern age's technological advancements have vastly improved the safety and efficacy of maritime operations. The creation of self-righting boats is a prime example of how innovation and engineering can come together to solve practical challenges, especially in high-risk environments such as rescue operations at sea. These ships, equipped with advanced systems and unique design features, can withstand harsh conditions, maintain their balance, and continue their mission even when capsized. The meticulous attention to details, from weight distribution to watertight compartments and the inclusion of automatic systems, demonstrates the extensive planning and foresight in this field. The development of such ships signifies a massive leap forward in maritime safety, ensuring more effective rescue operations and greater survival chances for those facing distress at sea. The evolution of such technologies will undoubtedly continue to push boundaries and further enhance safety and efficiency in the maritime domain. Thanks for watching Ocean Files, and I'll see you in the next one.